Hello everyone. Today I'm going to explain about instruction set in 8086 microprocessor. Okay. So first of all, what is instruction set? Instruction set means a group of instructions or set of instructions. To execute it is a instructions, set of instructions, and these set of instructions are used to perform or execute perform or execute any specific task. Any specific task. Okay. So now in 8086, the total instruction set is classified into different groups. Okay. So now let us discuss what are those groups. The first classification is data transfer instructions. Data transfer instructions. Second one is arithmetical instructions. Arithmetical instructions. Third one is logical instructions. Logical instructions. Fourth one is processor controlled processor controlled instructions. Processor controlled instructions. Fifth one is string instructions. String instructions. Sixth one is branch instructions. Branch or program controlled instructions. Okay. So this is the a classification of total instruction set in 8086. Now, out of these, in each and every category, there are different types of instructions. So it will become a very lengthy video. So that's why I will explain one by one group of instructions in each and every video. So now in this video, I'm going to explain about the data transfer instructions. Okay. Now, first, the data transfer instructions. What is meant by this data transfer instructions? That means the data is transferred from one location to another location, or the data is transferred from one operand to another operand. That means this source operand to destination operand. So here, what is source operand and what can be the destination operand? So in this type of instructions, okay, in this the data is transferred, the data is transferred, or it is also called as the copied. The data is transferred or copied from one location to another location. Okay, one location to another location, one location to another location. Okay, what is that is? So that is from source to destination, source position to source position to destination position. Okay, source position to destination position. So now what can be a source or what can be a destination? Here the immediate data can be transferred to register, or immediate data can be transferred to memory location, or the data from a register is transferred to another register. Okay, so likewise, in these types, the data can be transferred. This immediate data, it is an immediate data. That means the data is available in the instruction itself. Immediate data. Okay. This is also same. That means the data is available in the instruction itself. Data is available in the instruction itself. Instruction itself. This is the immediate data. Now let us, what is the examples? Okay. For example, the first category, for example, move AL comma 27 hexa. Move AL comma 27 hexa means, move AL comma 27 hexa means, that means the 27 is immediate data. It is a 8-bit immediate data. That is, it is in the source position. It is in the source position and this is the destination position. Okay. So the data is copied into the AL register. Okay. So that means now after this execution of this instruction, AL contents becomes 27 hexa. Okay. Similarly, we can, this is an 8-bit immediate number. Okay. It is 8-bit immediate data. Immediate data. Okay. Immediate operand. Or similarly 16-bit also we can use. Move AX comma, for example, 2025 hexa. That is hexadecimal number. Okay. So that means this number is copied into the AX register. So immediate data is copied into the register. This immediate data is either 8-bit or 16-bit. Similarly, immediate data can be transferred to memory location also. Okay, immediate data can be transferred to memory location also. So move uh, bx move bx comma 27 hexa, for example. Then what happens? So this is the 27 is the immediate number. That immediate number is transferred to memory location. Already I mentioned in the previous videos, once we specified in a brackets, square brackets, it represents the memory location and the bx register contents acts as a effective address. Okay, BX register contents acts as a effective address. With that effective address, the physical address can be calculated. With that physical address, one memory location is identified. To that memory location, that 27 is transferred. Okay, simply BX register contents acts as a effective address. Okay, so with this effective address, physical address will be calculated. Physical address will be calculated. Okay. Now calculated. Now with this physical address, memory location is identified. Memory location is identified. Memory location is identified. Now once this memory location is identified, this 27 is transferred. 27 is transferred to this memory location. This 27 immediate data is transferred to memory location. Okay. Similarly, register to register. Register to register means what? Move, simply move AL comma BL. That means BL register contents are transferred to AL. Similarly, move AL comma CL. That means CL register contents are transferred to AL register contents. That is register to register. Just copied. Okay. This is one type of data transfer instructions. Okay. Next, another type of data transfer instructions. Another type of all move instructions comes under the data transfer instructions. Similarly, exchange. Okay. Exchange instructions comes under this data transfer instructions. Similarly, in, out, push, pop, load, effective address, load, data segment. Okay, next low L LAHF LAHF, similarly SAHF. These are all comes under the data transfer instructions. Okay, so now move instructions already we have discussed. Now exchange instructions. Exchange instructions means what is the difference between move and exchange. Okay, for example, move AX comma BX, for example. Then what happens? Just before this, otherwise I can tell with the example, just one example. Suppose AX is equal to 2500 hexa, BX is equal to 3500 hexa. Okay, this is before the instruction. Now move AX comma BX, move AX comma BX. Then after execution, what happens? After execution, what happens? AX, BX register contents are transferred to AX. So then AX register becomes 3500 hexadecimal number, and BX register contents also same 3500 hexa. Just BX register contents are copied into AX, but BX register contents remains the same. Okay, so only destination which was changed, whereas the same kind exchange, for example, XG, HG, exchange AX comma BX. Then what happens? Before the instruction AX contains 2500, BX contains 3500. But after this instruction, AX contents changes to 3500 hexa, and BX register contents are changed to 2500 hexa. These are exchanged. Okay. BX contents are loaded into AX contents are loaded into BX. That is the difference between move and exchange. Similarly, in and out. These are the input output port instructions. Okay. The example, this is one example. This is one example. Okay. Next, in instruction. For example, in instruction. In instruction means in AL comma 98 hexa. Okay, here this 98, this 98 is the port address. This 98 hexa is the input port address. Okay, input port address, 8-bit input port address. Okay, so then what happens? This 98 hexa acts as a address. With this address, one IO port is identified. In this input port, whatever the data is, for example, available, that data is transferred to AL register. The data is transferred to AL register. Now, the similar kind of instruction, for example, if I write move AL comma 98 hexa, move AL comma 98 hexa, this is in AL comma 98 hexa. In this move AL comma 98 hexa, this 98 acts as a data, immediate data. That data is directly copied into AL. That means AL becomes 98. Okay, but here this 98 is the address. With this address, the port is identified. Within that port, whatever the data is available, that data is copied into the AL register. Here directly this immediate data is copied into the AL register. That is the difference between in AL comma 98 hexa and move AL comma 98 hexa. Okay. Similarly, next one is the out. Out means that is out. Okay, out, for example, 98 hexa, comma, AL. Okay, so then what happens? Out, that means we are sending the data. We are sending the data to output port. We are sending the data to output port. So that's why the output port address should be in the destination position. Okay, so here the AL contents, AL register contents are transferred to AL register contents are transferred to AL register contents are transferred to output port. Okay, output port, which whose address is 98 hexa. Okay, so that means 98 hexa is acts as a 98 hexa is acts as a address of output port, and AL register contents are transferred to output port. Here the input port is identified. In this, the input port data is transferred to AL. Here, AL register contents are transferred to output port. AL register contents are sending. Output port means sending. Input port means we are receiving the data from input port. Output port means we are sending the data to output port. Okay, so this is the in out. Okay, next push pop. Okay, next push pop. So that is push instruction and pop instruction. Push instruction and pop instruction, these are particularly used in the stack segment or stack operations. Okay, stack segment or stack operations, these are called as the stack segment relevant instructions. Okay, so push means it is used to insert the data or sending the data to the stack segment. Okay, to the top of the stack segment. Pop means pop instruction is used for retrieving the data from the top of the stack segment. Okay, so this instruction is used to store or send or to copy, whatever it may be. Okay, to send the data to the top of the stack segment, top of the stack segment, and this is it is used to retrieve the data or taking the data back. Okay, retrieve the data from the top of the stack, okay. For example, uh, push AL, okay, or push AX, for example. Now what happens? For example, this is the stack segment. Okay, this is the stack segment. Already I told you segments. Okay, this is the stack segment locations. This is the stack segment locations. Stack segment locations. Okay, for example, currently the stack segment is in this position. Okay, stack segment to top. This is, for example, this is stack top at that position, at that moment of, this is the stack top. Now we have given push AL. For example, AL contains 28 hexa, 8-bit number. Okay, so then what happens? So this 28 number is loaded into the 28 number is loaded into the this stack top, whatever it is showing, that is it is stack top 28 hexa. Okay, then it is incremented by 1, then it is incremented by 1. Now currently the stack top it is showing like this. Okay, so this time suppose for example if we are giving push AX means what? AH and AL combination. So this is 28, for example this is 35 hexa. So then what happens? Push AX means first AL register contents are copied here and it is incremented by 1. Then the 35. Okay, AH contents are, this is AL register contents, this is AH register contents. Again it is incremented by 1. So now this is the stack top. It is showing the stack top. This is the push instruction operation. Now pop instruction. For the same, now we are retrieving back the data from the top of the stack. So for example, if I am giving pop AX, similarly pop AL, for example, simply pop AX. Suppose if I am giving the pop AX, currently it is showing the top like this. When I am giving the pop AX, that then what happens? First, the stack top is decremented by 1. Okay, stack stack top is decremented by 1. Decremented by 1. AH register contents taken back. Okay, AH register contents. Okay, pop AX. That means this number, this number is copied into the AH. Similarly, next again it is decremented by 1. Now this number is copied into the AL. Previously, AL register contents are copied into stack segment. Now same reverse operation. Now from stack to AX, stack to AX. Okay, that is the in the pop the stack segment register contents are decremented. In the push the contents are incremented. Address is incremented. That is the difference between push and pop. Okay. Next, what are the previous instructions? Load effective address. Load effective address. Okay. Load effective address means LEA. Okay. LEA. Load effective address. Load effective address. Load effective address. Okay. That means, for example, LEA. LEA effective address. SI, comma 2000 hex, for example. Then what happens? The SI carries source index register, carries effective address, effective address. Okay. SI is used to carry the effective address. Now the 2000 hexadecimal, it is a 16-bit effective address. 16-bit effective address is copied to 16-bit effective address is copied to source index register. Source index register. Okay. Source index register. That is LEA. Similarly, LEA BX, comma 3005 hexa. Similarly, BX register sometimes it is used for memory location pointer. So BX register also used to carry the effective address. Same, this 3005 hexa number is copied into BX register. Okay, so that is the load effective address. Next, next, next example is LAHF. That means load AH register, load AH register with the lower byte of flag register. Lower byte of flag register. Already we know that flag register is a 16-bit. Okay, flag register is a 16-bit. In this, it is a 16-bit. Okay, it is a 16-bit flag register. Flag register is a 16-bit. It is a lower byte. This is higher byte or upper byte. Okay, now this lower byte flag register is copied into the AL register. That is LAHF. Okay. Similarly, SAHF. Another instruction, SAHF. This is load. This is load. Load AH register with lower byte of the flag register. Now this is SAHF. That means what? Store AH register contents. Store AH register contents to lower byte of the flag register. Flag register. That means this is again flag register. Again, this is the lower byte. This is upper byte or higher byte. Now, AH register contents are stored. AH register contents are stored into the lower byte of the flag register. Here, lower byte of the flag register are copied into the AH register. Okay. So, likewise, this is the these are the different first instruction set. What is the classification of instruction set? Data transfer instructions, arithmetical instructions, logical instructions, processor controlled instructions, string instructions, and branch program controlled instructions. Okay. In this first data transfer instructions we have discussed. All data transfer instructions. What are the various kinds of data transfer instructions? Okay. This is the move instructions, exchange instructions, in instructions, out instructions, push, pop, load effective address, load data segment, and LAHF, SAHF. Okay. So how many types of again move instructions? So move instructions, how many times? That is register to immediate data to register, immediate data to memory location, or register to register. All these are all the move instructions. Okay, all these are all the move instructions. Similarly, that immediate number can be a 16-bit also. Okay, this is register to register. Similarly, exchange instructions. What is the difference between move and exchange? I already explained. And in instructions, in this, the 98, it is a number, but it acts as a address of the input port. Here, the 98 in the move instruction, this 98 acts as a this immediate data. Okay, similarly, out instructions and push, pop. These are the two stack relevant instructions. Push is to store the data into stack segment. Pop is for to retrieve back the store. Okay. And load effective address LAHF, SAHF. Okay. So this is the data transfer instructions. Thank you.